Hello again. My name is Nina. I'm a front-end engineer at Evil Martians. We are engaged in product development for both startups and large companies, and we are also actively developing our own open source products. And I will tell you about one of them. But first, I got a problem. When I first started learning developing, I really was attracted by front-end because I could see the visualized result of my work very quickly. And there was a time when 3 tools were enough. And developers learned HTML, CSS, and JavaScript, and then we were able to build front-end parts of applications of any complexity. But the world of web development has changed quickly, and now 3 tools are usually not enough. That's what we have today. A lot of different package managers, build tools, linters, libraries, and frameworks. And all this started when we got frameworks. We believed that frameworks would give us convenience and significantly increase the speed of our development and make it much easier. But what we eventually received? The modern web development world is becoming more and more complex every year. And the most crucial part of it is that we suffer from it. We suffer, developers suffer, because we are the first one who meets the bad consequences of our own products. And we are drowning in frameworks and different libraries and utilities for frameworks. But what is the result? Did we receive that convenience? I personally think that we didn't, and our web development world remains complex, and we still need to do a lot of action to build something simple. Because when I start working on the project, I need to set up environment. I need to set up testing environment, add linters, JS and CSS preprocessors, and more. So we still need to put a lot of efforts to achieve the result. The second part of people who are suffering from web development complexity are users. And you know, if users suffer, everyone else will suffer later. But the important fact here is that the average web page size is growing every year. And if 12 years ago the average web page size was about 800 kilobytes, then 2 years ago it was already about 2,300 kilobytes. And that's a very big growth. And the more code, the more complex tools, the larger the web page size, and the slower load time. And the slower load time is actually a huge problem for users. How long do you usually wait for a site to load before you're trying to find information somewhere else? The statistics shows that every second is important to not lose a user. And finally, business also suffers from increasing complexity of web development world. And not only because developers burn out or because of user losses. Because, as I said, we still need to put a lot of effort to achieve the same results. And if we add the necessity to support all legacy code, to maintain it, to resolve conflicts between old and new code, and we also need to implement new features, of course, sometimes we receive the situation when business need to hire even more people and more programmers needed to do the same amount of work. And it means that both money and times are wasted, which, as you know, is crucial for business. Let's sum up. From the growing complexity of web development world suffer everyone, developers, users, business, and the situation didn't become better, it's even becoming worse. Maybe we need to change something and make a step back. Let's try to find inspiration and listen to wise ideas from the recognizable developers in our community. Fold knowledge into data. So program logic can be stupid and robust. That's a quote from Eric Raymond, open source ideologist and author of the book The Art of Programming for Unix. In this book, he presented a number of rules for minimalistic modular software development, and that was a rule of representation. Let's try to apply this idea to our problem. The current web development world revolves around frameworks. And when we install some new libraries in our project, we usually firstly check if this library is compatible with our framework. And some libraries are developed particularly for some frameworks. And also, frameworks now are responsible not for only how we show information, but how we implement business logic, how we implement different features, and many more other things. That all can be presented as a space model where framework is inside the web development world and everything else revolves around this. But the more work components in framework do, the harder it is to test, to maintain, and to change. And you know, there was a time when people believed that in the center of our world is the Earth and not the Sun. And all the celestial bodies revolve around the Earth and not the Sun. So maybe we made the very same mistake. And maybe we need to change our focus from frameworks to data, as is an idea, fold knowledge into data. Then we see that we move focus to data, and everything else will revolve around data. But what exactly do I mean by the concept of data? What is a well-known process in web development world when we manipulate and store some data? I'm talking about state management. Basically, that's the process of maintaining knowledge about application between different its parts. And in the concept of state management, we have a concept of stores as appropriate places when we store data. So, to move from the framework-centric concept to data-centric concept, we need to move stores outside of components, to make components be stupid and robust. And stores will be more smart, they will contain the logic, they will provide the needed logic to components, and they will be independent from frameworks. Let's remember this idea. We move logic inside stores, move them outside of components. Let's try to find more inspiration. Bad programmers worry about code. Good programmers worry about data structures and their relationships. And that's a quote from Linus Torvalds, a lead developer of Linux kernel. And he emphasized the idea that actually before writing the code, we need to think more about architecture and data structure. And the very popular approach with state management, both now and a lot of years ago, is a popular approach with global object. And in this concept, we have some huge global object that contains all the data for our application. But it's not really optimized. Sometimes our chunk may contain data that is not currently presented on the user's page. And also components need to call the selector function every time when fields inside the global store state change. So let's try to optimize a bit our architecture and make it faster. And we can find inspiration in the concept from reactive programming, which is called observer pattern. In this pattern, we have an object that is called observable, and the state of observable can change. And we also have multiple other objects that are called observers. Observers can register themselves as subscribers, and subscribers can subscribe to observable object and receive automatically the changes from it. Let's try to apply this idea to state management and our framework concept. Therefore, we make stores as observables and components as subscribers. So components should subscribe to the store's changes and receive the updated value automatically. And that will be closer to the idea of observable pattern. But we also don't have a strict restriction that we need to have only one huge global object that stores all the data. We can make a lot of small stores so our components can subscribe to only needed data, and it will be faster and optimized. But in the real world, of course, there are more complex cases, and especially when some data depends on other data, how we should handle this case. The solution is to allow not only components subscribe to stores changes, but also to allow stores subscribe to other stores changes. So we will have the reactive chains of computations to update all the needed data. So store changes data inside it, send it to other store receives this value, updates its own data based on this, and then pass it to the component. Okay, we have figured out two ideas already. We move logic to stores outside of components, and we make stores small and smart. So not only components can subscribe to stores, but stores can subscribe to stores. Let's go further. And the next quote is not from the developer, but from the writer and aviator Antoine de Saint-Exupéry. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And that can be easily applied to development world too. When I first met the concept of state management, I tried to do something really simple. I was a beginner developer. I had to receive the username from the server and then display it in multiple parts of my application. And when I started browsing information about state management in Angular, the first thing that I found was such a scheme. With a lot of different entities like reducers, effects, selectors, and with a lot of complex interactions between them. But actually everything that I had to do in my simple case was just receive the data from the server, set the value inside store, and then get this value from the store in my component. The less the mental overload, the less likely that we get confused in different complex entities. And the harder is code to understand, the harder is to maintain and to change. But by minimalistic and simple process, I don't mean oversimplification. As Albert Einstein once said, everything should be made as simple as possible, but no simpler. And we still have a lot of difficult tasks on our work, and we need our solution to consider different developer challenges. For example, we may want to synchronize changes between browser tabs, or implement navigation on our site based on the state in our application. Or we may want to resolve conflicts between different devices. And this list can be expanded more and more, depends on the project. So we need not just minimalistic solution, but also solution which is considered all these cases. And we don't need boilerplate for easy cases. No one likes a lot of boilerplate, isn't it? So we need to achieve a balance between easy cases and hard cases. Let's recap all the ideas that we just have come up with. First, move logic and stores outside of components and make them independent from framework. Also, we make the stores small and smart so they can subscribe to each other, and also let components to subscribe to their changes. A simple and minimalistic process ideally. So I would like to have just one line operations for creating store, get value from the store, and set a new value to the store. And the last thing, we don't need to forget about hard cases, and we need to consider the different developer challenges while we have a minimalistic solution. So, me and other evil Martians were thinking a lot about what state manager will solve all our problems and suit all the requirements, and we didn't figure out. So, for our needs, we developed our own solution. It's called Nano Stores. Nano Stores is because its size is less than 1,000 bytes, and its ideology is completely built around all the principles I just told you about. But hold on, we are all Angular developers here, right? And now you may want to ask me, Nina, but what about Angular signals? The groundbreaking change that was introduced in Angular 16th. Why do we need Nano Stores when we have such a great solution? And I will answer, I love signals. It's a great tool indeed, and I love using them. But there are three cases where Nano Stores have a huge advantage, and I will tell you about them. First, Nano Stores has its own powerful ecosystem. It has a lot of smart, tiny stores, which allow us to perform different developer tasks very easily. For example, if you want to save data to local storage and connect it with stores, we have a solution for it. If you want to make the content of an application fully translatable, we also have another solution. And if you want to add smart remote data fetching, it also has a solution ecosystem, and all of this can be implemented in a few lines. I will show you an example of one of the solutions in practice a little bit later, but let's move forward to other specific features of Nano Stores. The second one, Nano Stores are not depend on particular framework. As the first part of solution, stores themselves, they are completely framework agnostic. You can just install the core package or any solutions from the ecosystem just as is and use them in any framework. And to make the stores work seamlessly with any framework's components, we have integrations for all the modern frameworks, besides Angular, like React, Vue, Svelte, Solid, Lead. And if you are switching between projects that are written in different frameworks, like me, that can be a huge advantage for you, because that's a single solution for all the cases. And the third reason why Angular developers are using Nano Stores is simple. A little bit sad, but simple. A lot of us still don't have a choice, because based on aggregated data from the beginning of this year, almost half of developers still didn't switch to the version of Angular where signals were presented, for various reasons. So when I supported Nano Stores for Angular, I just wanted to give the convenient solution for state management, not only for the projects with newest version of Angular, but also with the oldest ones. Okay, let's build a simple catalog using Nano Stores so you can see how it works in practice. We'll build a simple page with header, a list of Nano products and a search bar. When a user types something inside search bar, the products list will be automatically changed. To use our Nano Stores service in the Angular project seamlessly, we need to specify Nano Stores service in the providers array of our ng model. And we configure it to use Nano Stores service as an implementation of Nano Stores injection token. And all of this can be just imported from Nano Stores Angular library. So we create state.ts file and we import the atom function from Nano Stores. Atom function accepts one argument, which is initial state of our store. And here we just specify the initial list of our Nano products with name and price. And as we use TypeScript, we pass the value type as a type parameter in Angular brackets. We make the store exportable and use it inside a component. We create a catalog component and we import the Nano Stores service from Nano Stores Angular and we import the product store. And Nano Stores service has the method which is called useStore function, useStore method. And inside useStore we pass our created store. And we will receive the observable. We can use a sync pipe to just display the products inside our template. And here it is. Basically, we just created a store, provided Nano Stores service, and get value from the store in our component. Let's add the search input to work with our catalog. So when a user types something, the list of our products will be automatically filtered. We create Atom Store exactly the same way as we created Atom Store for the products list. And we pass just empty string inside it. So the search bar will be empty in the beginning. Then we use the Atom Store for search input inside our search bar component. And here we bind the value attribute of input to use our store, our fresh value of the store. And we also bind the input event to the function that updates the value inside store. So when the user types something, the value automatically updates inside store. Then we need to connect our list of products with our search bar. So we need to connect to Atom Stores. And for this, we use another function from Nano Stores, which is called computed, which basically allows store to change data based on other stores changes. And computed function accepts two parameters. First of them is array of stores from which our store is depend. And the second is the callback function that is invoked every time when value inside any of these stores is changing. So here in this callback function, we will just filter the values inside product list based on the current value inside search bar. And using computed store in the component is exactly the same as Atom function. So here we just use filtered products instead of our previous Atom stores. And we display the value exactly the same using a sync pipe. So here it is. The products will be automatically updated when a user types something. But in the real world situation, we usually don't store all the data on the client side. We usually receive it from server. And now I want to show you how the solution works with Nano Stores query. That's a solution to automatically receive the data from server, also refetch it when we need to validate that data, and how we can implement it. First, we define a fetcher context, which allows us to share the implementation of fetcher logic between all the fetcher stores in our application. And here we define a fetcher logic, and it's completely transport agnostic. You can use GraphQL, you can use REST, you can use anything that just returns simple promise. So here I just use fetch, plain fetch. And when we receive data from the fetch, we just parse it using JSON function. Then we create fetcher store using this default fetcher context. And create fetcher store function just returns the atom store, which is directly connected with all the keys that are listed in the first argument. Here, this store doesn't depend on any other stores, but so we just specify a plain string. But if we want to make it dependable from other stores, we can list all the stores that we want to, and the cache will be revalidated every time when value inside these stores change. Using fetcher stores is almost exactly the same as atom store or computed store, with a slight modification that inside subscribed value, we receive not only the list of products, we receive two fields. First one is a loading flag, which is shown if the data is still processing from the server or it is already uploaded, or it will be true when it is downloaded. And inside the content field, there will be a list of products, which is first undefined when the data is loading, and then we receive the array of products. So here we will show user spinner when the data is downloading from server. And when it is done, we will see the list of our products. All the fetch logic is highly customizable, so while creating a fetch and store, you can specify if you want to revalidate cache in specific interval, or when network restores, and more. We believe that moving to easy to understand processes is important and necessary. So the next time when you realize that you need to use a state manager in your own product, try to find a minimalistic approach. And just in case, Nano Stores will be ready to help you with it. Thank you for your attention.
Thank you very much, Nina. We have some question for you. So, how NanoStore works with large database? Do you have performance comparisons with Nginx or Redux?
It works basically exactly the same. As it's super minimalistic, it just can receive any objects or any arrays. It doesn't really, like we use it on a very large projects with big data, and it works perfectly.
Perfect. Then, what other state managers besides Nano Stores do you like?
I personally like Pinia as a state manager for Vue.js. It's quite minimalistic and well designed as well. Also, Effector for React, I like it. But for Angular, I don't remember really good alternatives. Actually, that's why I started this implementation.
And what other non-obvious benefits are there to using NanoStore besides their simplicity and minimalism?
Mm-hmm. I like using Nano Stores in terms of writing tests. You know, I don't like spending a lot of time writing tests, and when you use some state managers, it can be really complex and slow to write tests. But with Nano Stores, it's also completely fast, completely without issues. Yes, that's non-obvious advantage of it, I think.
Thank you very much, Nina. Again, please, a huge round of applause.